Hi, good afternoon. My name is Kristin Trippe. I'm a soil microbiologist at the USDA Agricultural Research Service in Corvallis, Oregon. Today, I want to tell you about a decision support toolkit that we created to help biochar users find a biochar that meets their specific soil and cropping needs. This work was done in collaboration with Adam Lindsley at Oregon State University and a postdoc in my laboratory, Claire Phillips, who's since moved on to the USDA in Ames, Iowa. Now, we all know that one of the super cool things about biochar is that it's tunable and we can manipulate the feedstock or the production or the post-production conditions to make a biochar with specific physicochemical properties. So, for example, I'm showing here two biochars, one made from poultry litter and one shown from hazelnut. And you can see that they look really different on a macro level, but they also look different at the molecular level. If we look at how the carbon is distributed in these biochars, you can see that poultry litter has a much higher fraction of ash and less stable carbon than the hazelnut biochar. But as you change the production temperature, the biochar properties change too, and the differences between these chars become more pronounced. In this case, the ash content of the poultry litter biochar continues to increase. So, for a farmer who's trying to address a nutrient deficiency or mitigate acidic soil, this means that poultry litter biochar, which is shown here in green, is probably a better product for their specific needs because it has a higher fertilizer value and it has a higher liming value than the hazelnut char, which is shown in gray. Now, this diversity is really neat because it allows us to match a specific biochar with a specific soil deficiency. But unless a farmer or a biochar user is armed with this information and information about their soil, they really can't make an informed decision or know which specific biochar to use. So to address this dilemma, our lab designed an online toolkit, the Pacific Northwest Biochar Atlas. And using this tool, users can identify their soil deficiencies and their biochar goals to make important cropping decisions. So here's the tool, and we have a function called the Soil Data Explorer, which allows you to look up using a map-based interface or results from a soil test to identify soil deficiency. They can also look up extension information about the needs of their specific crops. So here, for example, this user identified that they were very low in phosphorus. They can then use this information to identify and rank biochar user goals. For example, they can choose carbon sequestration, water holding capacity, increasing pH, or increasing nutrients like phosphorus. Based on these goals, the tool will recommend specific biochars that have the ability to meet crop and soil needs. Then, armed with this information, the user can perform a cost-benefit analysis based on input and application cost and projected yield increases. Now, the tool has many other functions, including general information about biochar, case studies, links to scientific literature, and a whole other functionality that allows one to compare biochars side by side. I encourage you to check it out at www.pnwbiochar.org and to contact me at the email address at the bottom if you'd like to create content or if you have feedback on how we can improve the tool. Thanks for listening, and I hope you enjoy the rest of the talks.